to ladies and gentlemen. Before I start, I would like to introduce myself. My name is Mr. Lee Chuan. You can call me YC Lee. I'm actually the CEO of Proton Global Services, a fully owned subsidiary of our national car, Proton. So today, the topic is, of course, related to automotive sector, so entitled Greening the Automotive Ecosystem. So just a little bit background on my side is I am a mechanical engineer by profession, but I has 5 years experience in doing EE, energy efficiency and renewable energy projects in Proton, because back in 2013, we have a high utility cost. So that time, the management asked us to form a team to actually spearhead the green initiative for Proton. So that was started back in 2013, all the way until 2017, where I was reassigned to another position. So during that 5 years, actually we have implemented some projects which I will share in detail later, like the 12 megawatt peak solar project in Tanjung Malim plant, our 400 tons magnetic chiller in our headquarters in the Proton Center of Excellence in Shah Alam. Also, we introduced the energy management system, which was actually part of the initiative under the United Nations Industrial Development Organization, UNIDO, back in 2014 to 2016. So Proton was part of it, and we have trained some of our energy management experts under the UNIDO program. And myself is also a registered electrical energy with Energy Commission, ST, and also certified professional in MMV, as well as the energy management expert. Okay? So let's start for the automotive. Before that, I would like to give you maybe a glance on the carbon footprint for the auto industry, especially the transport industry. So we all know that what is carbon emission. Basically, carbon emission or carbon footprint is basically the greenhouse gases. As we all know, greenhouse gases, there are many, but majority, 76% actually in the atmosphere is actually carbon dioxide, CO2. And the rest, like methane, which is 16%, and nitrous oxide and the others, they are all grouped together, what we call it CO2e, which is CO2 equivalent. Okay? And out of the carbon dioxide in the atmosphere, 65% is from fossil fuel. The petrol or diesel car and trucks and so on that we use every day, 65%, and industrial processes, 11% for deforestation and degradation of soil, and methane mainly is from farming, agriculture. So Malaysia, also we have a lot of farms, so we have methane released to the atmosphere. And nitrous oxide basically is from the fertilizer users in the plantation industry. And the rest is the refrigerant, the SF6, HFC, PFCs from industrial and processes and refrigeration. So if you look at the greenhouse gas distribution worldwide, 32% is from electricity and heat production, mainly the generating electricity that we use every day in our life. And another 15.3% I would like to highlight is from the transport industry, where we are with the automotive industry is part of the transport industry. So if we look at it, the global emission of greenhouse gas is about 54.6 billion metric tons of CO2 annually. So this is quite a huge amount if you look at that 54.6 billion. So most of the CO2 actually comes from 15.3% comes from transportation. And out of transportation, the passenger car, which is the car that we drive to work every day, motorcycle included, buses and taxis we take, and also the commercial vehicle, the trucks, the lorries on the road, they combine 74.5%. So emission from the transport sector is one of the main contributor to the CO2 carbon footprint. And the rest is aviation from shipping, and also the global shipping and rail. Okay. So let's look at Malaysia. How much Malaysia cars and trucks are emitting CO2? So this is the greenhouse gas from Malaysia vehicle on the road. So if we can look at the total industry volume, it's actually the new cars, new trucks that are sold every year from 2013 to 2023. You can see in the last 2 years, Malaysia TIV, total industry volume, has actually increasing. From the COVID time, we dropped to about 500,000, but we drastically rebound thanks to the SST exemption. A lot of people bought cars. So in 2022 and 2023, we have 720,000 to close to 800,000 last year. And this year is also will be close to that 800,000 figure. So Malaysia now is one of the highest sales of volume of passenger cars in the region. Right? We are actually, in fact, first half of this year, we actually surpassed Thailand, which Thailand always the number second or number one after Indonesia. But because of COVID, Indonesia dropped a lot, and Thailand also dropped this year. So we are actually now in ASEAN country, one of the highest sales of cars. Okay, and if you look at the car CO2 emission, the carbon dioxide emission by year, pickup is the highest. The one pickup, let's say pickup will emit 3,510 kg of CO2 per year, followed by large SUV. I think nowadays the trend is SUV. A lot of people like to drive SUV, but SUV, because of the higher engine capacity, they are actually emitting more carbon dioxide, about 2,005, followed by sports cars, luxury car, of course large car, until the small car. Even the small car that we drive on the road are also emitting about 1,470 CO2 per year, kg of CO2. So this is actually based on if you drive around 15,000 kilometers per year, which average about 1,000 km per month, which I think most of us do drive that distance. It's about 80 kilometers to 100 kilometers per day. So to put that in perspective, UIO is a unit in operation. Just now we mentioned it's just new car. The total industrial volume is new car. What about the old car? The car that is driven 5 years, 10 years, or even 15 years, because we don't have end-of-life vehicle regulation. So in Malaysia, there's a lot of cars still on the road. So that's what we call it UIO, the unit in operation. So in calculation, I just take 10 years car. Those that are above 10 years, I don't calculate because it's quite old. Some are already demolished. So out of 10 years car we have in running on the road is 6.1 million. Compared to our population of 30 million, it's like every 5% we have one car, including children and old folks. So there's quite a lot. And out of it, majority, 5.4 million is passenger car. The car that we drive every day is part of it. And only the commercial vehicle is only 0.7 million, so it's not a lot. So average emission per car that we emit, an average 1,005 kg of CO2 per year. Of course, commercial vehicle being larger in size, bigger in engine capacity, they emit higher, 3,005 kg tons per year. So total, Malaysia automotive sector contribute around 10.5 billion metric ton per year of greenhouse gas. So that's a lot. So people are saying global warming, yeah, it's true. And automotive cars and trucks are putting more of CO2. So just to give you a perspective, how much is 10.5 billion tons of CO2? Because CO2 is a gas, we can't see it. It's equivalent to the weight of about 105,000 KL tower, the weight. Or if you put it in a smaller thing, like our car. This year we launched our new smart #3, so I just put it on EV. It's about 5.7 million of this EV, the weight of the CO2 emission per year that Malaysia cars and trucks are all emitting. So that is mind-boggling figures. So the next chapter, that is why now the automotive sector needs to spearhead to do more on carbon footprint reduction, carbon dioxide reduction. So ESG in automotive sector. Everyone knows ESG. These have been buzzword for the last 5 or 10 years. ESG stands for environment, social, and governance. So what is ESG actually about? ESG actually is a specific set of metrics where we have KPI, key performance indicator, that are used to assess and quantify a company's exposure to the environment, to the social, and the governance risks. So most of the large companies already have ESG compliant KPIs. And if not, a lot of going for it. Because why? ESG now has come down to investment and reporting. Banks are all ESG compliant, and a lot of investment firms and banks, they make ESG a priority, a top priority. If your business, you want to take a loan, a business loan, if you have ESG compliant, you have green initiative, most likely you have a higher score, the bank are more willing to loan you. And if you are doing a project that have ESG element in it, you have, example, environment initiative, so they are willing, let's say solar project, we are reducing the carbon footprint, right? So banks are willing to loan for this type of projects. So if you are doing fossil fuel, you are a coal mine, example, right? You put a lot of pollution, you very hard to get loan nowadays. So these are the changes the world are experiencing. So in our view, ESG is here to stay. So a lot of SME in Malaysia are not ready yet. So we hope that through awareness talk like this and so on, we can actually motivate them, the owners of this SME, to actually start to put ESG a priority in their business. Later, I'll share you why ESG is important. Okay, first we talk about how ESG will benefit the industry, especially the automotive industry. First thing is it will improve your business performance because you have ESG KPI I mentioned just now. For example, one of the KPI is to reduce carbon footprint, is to reduce the utility costs. So your cost of business go down, your profit goes up. So this improves your business P&L, your bottom line. Second, reduce your business risk because the regulations are getting tighter and tighter. So if you are ESG compliant, means you comply to the latest set of regulation, be it from financial to the environment. So your business are actually safeguarded. And it creates positive impact for a company that is sustainable. They call it ESG compliant. A lot of people will like to do business with you, right? People from, let's say, companies from Europe, from US, they are more willing to do business with Asian companies that have ESG or compliance or sustainability features. And easy access to financing, just now I mentioned. Banks are more willing to loan you loans if you are ESG compliant. So that is very important because business needs loans to grow. And you attract talent. Youngsters nowadays, fresh grads and so on, they are more environment conscious. They want to save the earth, they don't want to pollute, they want to go for use EVs and so on. So if you have, your company has a good ESG policy and a good framework, you tend to attract talent, right? And also investment. New investor may like to invest. There are actually, example, there are funds overseas. They actually look for companies that have sustainability rating, like the FTSE4Good index. If you have a high rating, so the investor funds from overseas, they tend to invest, if you are public listed, that is, okay? And it's always a good branding and good for CSR if you have a good ESG initiative. And for those companies that you're exporting your products, let's say semiconductor products and so on to US and Europe. So if you have ESG initiative in your policy, it's easier to do business with them. And finally, one of the most important one is you must prepare also for carbon tax implementation. So I have just done a slide just on what is carbon tax. This may be a new term, but I think a lot of people heard of it. Carbon tax, carbon pricing, carbon mechanism is similar. So carbon tax or carbon pricing is actually an economic incentive for businesses to reduce your carbon emission. So if you can save and quantify your CO2 footprint and reduce it year on year, you will have a lower cost of greenhouse gas emission. However, if you do not embark on, let's say, energy efficiency, renewable energy, you will be taxed sooner. Of course, now Malaysia government have not implemented the carbon tax yet, but there are already papers being circulated by the ministry to study how much the carbon tax should we implement and when we should implement. I just give a comparison to our neighbor, Singapore. Singapore actually confirmed the carbon tax back 2 years ago in 2022. Malaysia, we proposed it much earlier in 2019, but until today we are not implemented. But Singapore has implemented it. And at the moment, Singapore government is implementing a carbon tax of 75 ringgit per ton of CO2 equivalent. So if you are polluting the environment, 1 ton of CO2, it will cost you 75 ringgit. So they plan a staggered increase all the way until 200 ringgit per ton. Why 200 ringgit? The real cost of carbon in Singapore is actually 230 ringgit per metric ton. So they are actually gearing to go up there. Malaysia, actually our real cost for carbon is actually 150 ringgit. So this is the real cost of carbon in Malaysia. However, the proposed one, we are actually starting quite low, around 30 ringgit, slowly going up to about 150. However, this has not been implemented. If this is implemented, we are on track. But unfortunately, it's not being implemented yet. So we need to be ready. If one day, maybe next year, if the government introduces carbon tax, so your carbon footprint of your company, let's say you have 10 tons of CO2 emission, you have to pay, if they put at 150, you have to pay 1,500 ringgit in tax. Unless you do something about it, you reduce your carbon footprint through EE or RE initiative, which I will share later how we do it. So if you fast forward to the future, Malaysia government has pledged to have net zero carbon by 2050, right, by our government. So by 2050, most of the world advanced and developing countries would have pledge a net zero carbon country. So based on the International Energy Agency and the World Bank, they are forecasting developing nation, the carbon tax will reach around 800 ringgit per ton by 2050. And if advanced economy is even higher, they will reach over 1,000 ringgit per metric ton. So we are still very low here and not yet implemented, but we need to be ready. I can assume that more than 95% of Malaysian companies, including SME and GLC, they are not ready yet. But we have to start somewhere. If not, when the day comes, we'll be scrambling to do a lot of EE and IE initiative, reduce our carbon footprint. So why not we start early now? It can also help our utility costs. So this is very important, okay? Okay, how do we practice ESG? I put it in, this is actually a very simple guideline. You can do it in not just the automotive industry. So business that adopt ESG practices can improve performance, like I mentioned, the financial performance, can reduce your business risk, create positive impact, attract talent, and so on. So first thing on environment. What is ESG about in the environment is how is your business operating, impacting the environment. Example, if you are a factory, do you have any emission? Do you burn any fuel? Do you emit any gases and GHG gas, greenhouse gas to the environment? If yes, then you are having carbon footprint. So you have to look at how you use your energy. Energy means electricity, thermal energy, heat. You burn gas to generate heat, is also energy, and water as well. Because if you have cleaning process, you use a lot of process water in your industrial process, you are also using energy. So you need to monitor your usage of energy and think of ways to reduce them. And you must discharge your water responsibility into the river. For factories like Proton, we actually went through a series of wastewater treatment plant so that the water we discharge to the river follow the environment, the DEA policy, example, the Schedule A. Yeah. So also reducing carbon footprint, the carbon emission I mentioned just now. Okay. Second is your social. Social means impacting how your company practices impacting the society in terms of your staff. Do you have diversity, diversified staff? You have any gender equality, male and female staff? Your community, how you contribute back to the community that you're operating in. Do you do a lot of CSR work? And also a labor relation. You have unions and so on. Your relationship between the management and the labor union are very good. And diversified inclusion are the keywords under the social aspect. So the last one is governance. So how does your organizational management practices, your internal systems, your controls, your procedure are impacting the way you do business? So I will not go very detailed. These are all you can just Google online, the board diversity and compensation, risk management, transparency, and compliance to regulation. So these are, I think, most of the company you have. Okay. Okay. The third thing is, today I want to share how do we practice energy efficiency and renewable energy projects in Proton. We have been doing this since 2013, okay? So I give you some real-life case study here. Okay, before I go into detail, I would like to share a very basic yet fundamental guiding principle of reducing your energy. It's called an energy pyramid. So if you look at a pyramid here, at the bottom, the first phase is the energy conservation. When we start for reducing energy, we always start with energy conservation, meaning we conserve the energy that you use today. Don't go into big investment. A lot of factories, a lot of companies, they don't know. People approach them, hey, just install solar. You immediately can save. But solar is the last you should invest. Why? Because it is high cost and it is at the top pyramid. You should start with saving your energy first. Example, you are using 1,000 kilowatt hour, maybe 1,000 ringgit in bill. But you install a solar just to cover the 1,000. But in reality, out of the 1,000 kilowatt you use, you have wastages, right? Example, your aircon is set at 18 degrees instead of 24. Example, your compressed air system have leakages, but you are pumping it, you don't know that you are leaking out the money, the wastages. So you don't eliminate all these wastages, you just go direct into renewable, like solar. You're actually investing bigger system to cater for losses. So we study under UNIDO, we always refer to the energy pyramid. We started with energy conservation. And energy conservation is one good thing is the investment is low to even zero investment. Operational change, optimizing controls. So they are very low investment, okay? Once you get the low-hanging fruit, we call it, you can easily get 10 to 15% from your current energy baseline. So Proton started it, first 2 years from 2013 to 2015, we do energy conservation, we actually save 16% from our energy bill without investment, just changing our parameters. Example, we get to set 24 degrees Celsius at all our aircon in the building. Even I went to the extent where we have chiller centralized aircon, I set the AHU temperature at each of the AHU at 24 degrees so that it's not so cold. You don't need to wear a jacket in Malaysia, it's a hot climate country. So if you need to wear a jacket in indoor, means your temperature is too low. You are wasting energy. This is one of the things. Aircon actually constitutes 60% of energy consumption in a commercial building. Yes, so if you save your aircon cost, you can save a lot. Second is, example, our HQ, we work from 8 o'clock to 5:30. So we have a centralized chiller and AHU, which we on at 7 o'clock to cool down the building, because overnight, there's hot air accumulate. The temperature can reach 30 degrees. So when the worker come in, if we don't on the aircon at 7 o'clock, they come in at 8 o'clock, they will complain very hot, right? And we always on it until 7 p.m., until everybody, the last body go back. But what I did is that I don't on the chiller first, because chiller is using a lot of energy. I on our AHU, the fan. I on the fan at 7 o'clock to flush out the hot air accumulate in our building overnight. So immediately, the temperature dropped from 30 degrees to 28, because the outside air in the morning is around 24, 25. So I suck in the outside air, I flush out the hot air. Then at 7:30 and 7:45 only, I start to on 1 or 2 second chiller. We need 2 chillers to run. So I save half an hour to 45 minutes running of a chiller. That can save about few thousand running costs a day. And then after whole day at 5:30, when we start to leave the work, I don't off my chiller at 5 o'clock. Then I keep my fans running, my AHU running, because there's a cool air, residual cooling here. I just keep the running so that we feel the air movement. So the building takes 1 hour to heat up, to hot. So after 1 hour by 6, most of the workers are left already. So by doing this without investment, I just change the parameter control. We save 20% of our electricity bill. Our headquarter bill used to be at around 280,000 ringgit per month. Currently, it is 150,000 ringgit per month. Same operating time, same number of people, about 700 people in the building, but by just changing some of these things, we managed to bring down the cost a lot. So actually, energy saving is not just about investment. You can do a lot of zero cost initiative just by fine-tuning your control and so on. This is just for office. If I talk on a production plant example, I mentioned just how compressed air leakages. So I'm not sure a lot of if you own a factory, you probably have compressor, right? You have compressed piping. So compressed piping over the years, it tends to leak, and we can hear the hissing sound. But usually during production, you cannot hear. So the key is you doing lunchtime, maybe 1 to 2, you take a walk down your production line, you will hear the hissing sound. Try to identify where the leakages is. If you can't hear, you can hear it, but you can't find it. Nowadays, there's an ultrasonic leak detector. We bought one. We can actually use the leak detector to detect where the leakages is, how severe is the leakages. So you can plug the leakages. Once you identify, you have a team just to go around your plant, around the clock, to identify leakages. Ask your maintenance team to do this, because they are not maintaining the equipment every day, but not every day got equipment breakdown. So you ask them to go around and do this process. By identifying the leakages, plug the leakages, we notice our plant air compressor demand actually dropped by 10%. So then I can switch off one of my compressor. Instead, last time I used to run 6 compressors, now I maybe run 5. Switching off one compressor, our compressor is quite big, about 350 kilowatt. So we save about 1 million ringgit a year. So Toyota has been doing this actually, just for your best practices in automotive. Toyota has a full-time, they call it a compressed air attack team. They go around their plant globally to detect, identify leakages and plug them. So this is something that we should learn. We should actually learn. I mean, not just automotive, other industry that use compressed air, please check. Because if not, you are spending a lot of money to compress the air, and then it's leaking out to the environment. Actually, in our workshop, we have a lot of proton workshop, also have compressed air. We also did the things. We went around with our ultrasonic leak detector, we detect, and we plug it. So we can reduce the compressor pressure. So it used to be we run at 10 bar. Now we can reduce to 7 bars. Even now going to 6 point something bar. Reduction of 1 bar actually save about 4 or 5% of the energy cost for a compressor, because you don't need that high pressure already, because you plug all the leakages. Those are artificial demand. Yeah. Okay. So after you've done the energy conservation, the second thing we go is we have got some saving already at hand. So we go for a higher investment grade, which is a medium investment, maybe 100K to 3 million, energy efficiency. So here you can save easily 15 to 35. So what we do is, you can purchase those 5-star Energy Star equipment. So we actually changed our chiller. Our chiller, I mentioned just now, is about 25 years old. So it's not so efficient. I changed the chiller. I spent about 2 million. Then I can reduce the aircon cost by another about 25,000 ringgit per month. So that's what we did. So we place it. And also we can change the lighting. I changed all our office lighting, our plant lighting from the conventional CFL tube to LED. So that can easily save you more than 50% of the lighting cost. So this, I mean, no-brainers. It's very easy to do this. Because then, as we progress, the low-hanging fruit are harvested. Next, we go for the renewable. So that is where in 2021, after 8 years of doing the EE and energy conservation, Proton invested in a 12 megawatt peak solar system in Tanjung Malim. So we invested, we get third party actually to invest, we have zero capex for us, but we get a saving of about 2.5 million a year for the next 25 years. So that's about 60 million. So these are things that we can do the pyramid. So I hope this is a simple thing, but something that for you to ponder, to think when you start to do energy saving. So these are the EC, Energy Conservation Initiative. Back in 2015, we have our energy manager. This first batch, we went for the training at the Energy Commission. So we got ourselves certified. So we start to do our own internal reporting, and we also do a lot of campaign, Hijau, green campaign. I give a lot of talks to share. And then I mentioned just now, we went to use the ultrasonic leak detector to detect at our workshop where is the compressor air leakages. So if red color is means severe, green is less. So we have energy team that go around to detect compressed air leakages. So these are just some energy conservation initiative. Okay, next, when you go to medium investment, EE, energy efficiency, it generates saving over 20 million for us since 2016 until now. So what we do, we change LED. So we change all the metal high bay in our plant to LED, and also in our office, we change it to LED. We changed our old chiller. This is the old chiller I mentioned just now, under York, 25 years old chiller. I changed to a multi-stack from China. It's a magnetic chiller. It actually, without need to have a oil change. Last time our old chiller, every year we need to spend 60,000 to change oil because it's oil cool. This one is air cool and there's no oil required. So I save maintenance as well. And because it's a magnetic, it's like the Shanghai maglev. When you run, the actually floating, the compressor is floating. So there is no friction. No friction, no heat loss. So it's more efficient. So I've been using this since 2015, I think, close to 9 years already. So I think it's quite okay for this chiller. Then we also put in a new compressor, air compressor. This is OPC, piston compressor. This is actually to help us to tackle the compressed air demand, because compressed air, you have a fluctuating demand. So usually the base demand, you use a centrifugal compressor, it's more efficient. But the high peak, just for a certain short period, you can use a OPC or a screw compressor just to tackle, so that you don't need to run too many centrifugal compressors. Because centrifugal compressor is very high energy usage. It's only good for constant demand. Fluctuating demand, you can use screw compressor. So you only on it for a short period of time. After that, the peak demand passed already, you just off it. So those are the things that we've done. And finally, RE, I mentioned just now, we invested in a 12 megawatt peak solar farm, started in May 2021. So far, we have reduced about 27,000 tons of CO2, and it will generate 65 million saving over 25 years, every year about 2.5 million. So this is zero capex, because that time we also don't have the big money to invest. In a 12 megawatt, at that time, the solar cost is still quite high. It's about 30 million. So we get a third party to invest, and we sign a 15 years SPPA, a solar power purchase agreement. Nowadays, there are a lot of third party investors who's willing to invest. I mean, if your company, you have your own cash, you can invest, then you start have maximize saving from day one. However, if you have cash flow issue, you want to focus your cash flow on your key business, but you don't want to left out to save energy, you can always engage third party. Third party, they are available, or get a loan from the bank. So they can give you the investment, and then you can enjoy also the saving. So third party, what they do is zero capex for us. They sign a 15 years contract. They build and operate the solar farm for 15 years. Operation maintenance cost under them, warranty under them for 15 years. Then they sell to us the electricity at a tariff lower than TMB. Yeah. So we also get saving with that. So you can always look for this. And this is, of course, also provide a car park for our car. After Proton car, before we ship out, we can have shading now. Last time it's open air. So this is added benefit. Okay. So this, we also flow down to not just our plant, to our dealers and vendors. So a lot of Proton dealership, if you look at it, nowadays you have a lot of 3S, 4S center. So we also encourage our dealer to invest in solar. So this is one of it in Kelantan. This one is in Puncak Jalil, I think. So they have invested in about 96 kilowatt solar system. So they have experienced, I think, saving of close to 50% and so on. So the next, I will show you just two future technology. One is on the renewable energy solar, another is on battery energy storage. So solar, we call it PV. PV means photovoltaic. Okay. So we look at the industry. Proton have a lot of vendors. They make components for us to make cars. So this is one of the vendor. I just, for confidentiality, I don't reveal their name and address. So their bill is 204,000 ringgit. So that's quite a lot per month for a small size plant. And they installed about 1 megawatt, 1.08 megawatt or 1080 kilowatt peak system, around 1,847 panels. They use string inverter. So every month they generate about 116,000 kilowatt hour. So average before, their bill is around 200,000. After investment, they save around 18%. Every month they save 36,000. So this is what they do in the industry. But we have actually over 300 vendors. Imagine if every vendor were to do this, how much CO2 we can reduce and how much the electricity cost they can reduce. Malaysia got plenty of sun, by the way, so why not we start this initiative. And dealer, just like I mentioned, the dealer is cost smaller, 96 kilowatt, just 192 panel, micro inverter. So this dealer, the solar system generate about 12,800 over kilowatt hour. So before install, the average monthly bill is 8,004. After install, their bill dropped to 3,002. This is the actual bill. This is the actual bill after install, 3,002. So they save monthly 5,000 ringgit, 61% saving for them. So we also have 150 over these dealers. So we are now encouraging them to one by one install the solar as well. But before go to the solar, always remember the energy pyramid. We will send our team to help them on the compressed air, on all the energy conservation and EE, change to LED lighting. Then when their bill start to reduce, then only we size the right solar for them. Don't always jump into solar, because if you jump into solar, after you start to reduce wastages, you will find your solar is oversized. So you generate more sun energy that you can use. So it's wasted. Right? Even house. This one I put a house. House also we install. It's a small one, 15.3 kilowatt, 28 panel. So used to be, it can actually generate around 1,000 kilowatt hour. So it's about 500 over ringgit. So before installing solar, the monthly bill was 663. So after installing, it dropped to 153 ringgit. So it's achieved about 77% saving or 500 over ringgit. So if you have landed property, you should actually go for solar nowadays. It is very affordable now, especially this last year. The solar cost has dropped a lot. So 1 kilowatt nowadays is about 2,000 ringgit. So you install about 15 kilowatt, it's around 30 to 40,000, about 40,000. Yeah. So you can get back your return within maybe 5-6 years already. And the solar panel manufacturer warranty lasts 25 years. So you can actually use it for 25 years. And even if the government were to decide to raise the tariff next year or so, you are not worried because you hedge already today your energy cost. The sun will not increase the rate every year. And they don't charge you also. Right, so why not make the most of it? Okay. So this is a trick that I think you all should do at home. Okay. Before that, I want to show you how TMB, our utility company, charge us. Actually, there are 4 main charges. Maybe some of you are aware, some of you not. We can take a look. First, they charge you on the consumption. For industrial, you have peak and off-peak. For residential, it's only flat rate. So this is the jumlah penggunaan, how much kilowatt hour you use. So you have times by the tariff, you get the ringgit. So this is the tariff rate. So this is actually an industrial tariff, E2, 35.5 cents. For peak, off-peak is 21.9. So for industrial, you have peak period, 8 a.m. to 10 p.m. Off-peak is 10 p.m. to 8 a.m. So at night is a cheaper rate. So if you may want to consider running some production nighttime, if it's, you can do it. And then you get charged another thing called maximum demand penalty. A lot of people are not aware, MD is measured in kilowatt. And for this E2 tariff, they charge you 37 ringgit per kilowatt. That's a lot, no? we are one of the highest MD after Singapore in the region. Singapore is number 1, in ASEAN we are 2nd. So we are, let's say if your MD is 827 kilowatt, you just multiply by 37, you're paying 30,000 plus a month, every month for MD. MD is the demand that the TMB meter, the incoming meter, measured every 30 minutes during peak time. And over the whole 1 month, the highest point, they lock it. So example, your factory, maybe for the first 29 days, you are having only 500 kilowatt. Suddenly, on the last day, you put in a new equipment, you test it, you go up to 800. Then they will lock you 800 and charge you that month based on 800. Not based on 29 days, I use 500, no. They charge you based on the highest point recorded in the interval of 30 minutes at any one point in time in that month. So that's how tough to save MD. Later I'll show you how we use battery to save MD. Yeah. UMA don't have. Residential, you don't have MD. Commercial, some commercial you have. The medium voltage commercial like C1, C2, you have MD. And their MD is even higher. I think C2 is 45 ringgit 10 cents. Okay, yes. So a lot of people are not aware, no? I mean, the owners here, you are not aware that actually your factory, your commercial one, the S have MD. Residential don't have, okay? And then on top of all your consumption charge, your MD charge, they add up. Then there's something called ICPT, imbalance cost pass-through, used to be subsidized. But last year, if you look back at the news, 1st January of 2023, the government increased the ICPT for the commercial and industry, increased 400% from subsidized to become 20 cents per kilowatt hour. Used to be 0.0 something. Then it went up to 20 cents. Then every 6 months, they adjust based on the coal price. So now it's about 16 cents per kilowatt hour. So last year, half year was 17 cents. First half was 20 cents. So on top of your consumption, they got this penalty ICPT, 20 cents. And ICPT nowadays, for residential, if you use more than 1,500 kilowatt, they charge you immediately 10 cents. So example, just now the house, if I use 1,000 kilowatt hour, I don't get charged. But if I use 1,501 kilowatt hour, the whole 1501, I have to pay additional 150 ringgit, well, 10 cents per kilowatt hour. So those with big houses or big aircons, with your consumption more than 1,500 kilowatt hour, be aware of this. If not, suddenly you see, my ICPT, I pay 100 ringgit for nothing. This is on top of the consumption charge. That's why my house also, I have personal experience, I kena one time. That's why I install solar already to reduce the consumption. Okay. So lastly, out of all your bill add up, maximum demand, consumption, and ICPT add up, they charge you a 1.6%. This one everyone pay, from residential, your house bill, to your commercial shop lot, to your factory, we all pay. If you don't believe, you go back, you look at TMB bill, and the bottom there's always this kumpulan wang tenaga yang boleh dibaharui, TKWTBB, 1.6% of your total bill, 2,000. This fund supposed to go to the SEDA. They collect it, so they give out projects, last time like FIT, now is LSS and so on, so it's supposed to fund the renewable energy transition in the country. So the less you use, the less KWTBB you pay. Okay. So how to save maximum demand today? We have been studying this. This is a photo I took in China. We went to there to study the battery energy storage system. In short, I call it BESS. Easy to remember, BESS. Okay. What is a BESS? Actually, it's a big power bank. I mean, we have a phone, the small power bank that we carry around. BESS is actually a bigger power bank. Of course, the industrial grade one can be as big as a 40-footer container. And the small one in the house one, maybe just like an aircon standing one. So what we have here is, we have the TMB power grid supplying us the power. Then this is our plant. We have a 12 megawatt solar. During daytime, we have this inverter convert the DC to AC, then used to all our production shop floor. So if in the daytime, I have excess energy from my solar, so I don't want to waste it, I store it in the battery energy storage, the BESS, the power bank. And then during rainy day, when the sun is not so good, because solar, one bad thing about it is it's not stable. So there is always shading, rainy, cloudy days, so you don't have solar. So that is the time where you can draw from BESS. Or at night time, during off-peak tariff, I charge the battery during a low tariff, 20 cents plus. Then I discharge it during daytime, where TMB is charging me 30 over cents. So I play with the energy arbitrage, the difference between peak and off-peak. Also can help me save money, right? And also reduce maximum demand, because maximum demand always happen during the peak period, 8 a.m. to 10 p.m. So this is where battery energy storage is very important. So to put it into an illustration, okay, this dotted line is our peak, okay, meaning the maximum demand load profile. So it doesn't stay flat. This is night time. That time our production equipment not running, so it's very low. But we still have some equipment running. Then when 8 o'clock we start work, it will slowly ramp up. Then you go up to nearly peak at 12 p.m. Then lunchtime, it drop back. 1 to 2, it drop back. Then after lunch, it went up again until peak at 3 or 4 p.m., where production is high. Then after 5:30, we stop production, it drop back. So actually, one day we have a few peak. So what MD charge, just now maximum demand, they pick the highest peak and charge you. So what I need to do is, I need to shift the peak. I cut the peak. So what I do is, the red color one is the energy I store in my battery. I charge it at night where there's no maximum demand. And I discharge it during the maximum demand time. So I shave it. So my load profile now is a flat. So I have saved the maximum demand from here. So this is actually a very good illustration that you should use a battery to charge at night and discharge it during daytime. Okay. So a battery, just for financial simulation only, it ranges from different sizes, different manufacturer. Investment for a 4 megawatt peak project we are talking about is about 6 over million. So 1 megawatt hour is about 1.5 million plus. So we estimated it can save us maximum demand of about 800 over thousand a year. And also energy arbitrage, the differences between peak and off-peak, you also get some saving. So about 100K. So roughly we get around saving about close to 1 million a year. So if we invest 6 million, our payback is about 6 years plus. Lithium iron phosphate battery, LFP, the battery life is 6,000 cycles. Nowadays commercial, some can go up to 10,000, but 6,000 is the average. So if you charge and discharge once a day, it's one cycle. So 1 year, 365, use 6,000 to divide, you actually can last for 16 years. Of course, the battery will degrade year to year, but in short, it can easily use more than 6 years. So that is a very good investment nowadays. China, US has all going into energy storage already. So we feel that energy storage is a way forward. Thank you. Of course, maximum demand in reality in our plant is not so easy like this graph because it actually fluctuates. This one is like every day 12 p.m. and 4 p.m. you get the maximum demand, but in reality it's not. So it's very hard to capture. So nowadays a lot of the BESS, they only have static control, meaning you can set to discharge at, let's say, around here. Let's say your maximum demand is 16 megawatt, so you want to shift 2 megawatt, you put at 40 megawatt. If it reaches 40 megawatt, you discharge. However, if you keep on discharging, then your battery will run out of juice. Then when there's another peak here, you cannot save enough battery to discharge. So what we need is, we want a battery to think smartly, like a human being. It can based on production, based on the solar production that they put it into the input based on historical load profile. It can think like human, and it can decide when to discharge, when to save. So that is what we call dynamic control. This is more into detail, but I try to put it in a layman term. AI, we use artificial intelligence and machine learning. So this is something that we are working with our partner. So artificial intelligence basically is to teach, is a software that we incorporate into the BESS to make it mimic human intelligence, to think like a human. So that we have, of course, logic, we have RBC rule-based control, decision tree, and so on, machine learning. We give them more data. Nowadays, people talk about big data, right? The more data you have, you put it into the software where there's an algorithm, a calculation formula, it can learn itself. That's called machine learning. So it's a subset of AI that when you put in more data, there are statistical techniques that enable the machine to improve over time. So we put that, we use our historical plant data, maybe 3 years, all the load profile, we put it into this software. And they have this algorithm inside that embedded the chip with the machine learning capability. And with that, it can actually forecast our maximum demand. Okay. So This is something that is a bit maybe dry. I give you a visual. Okay, the blue color one is actually the actual load profile of our plant. This is actual in Tanjung Malim, load building load. The dotted line is a forecast. So this is actually a snapshot of over a period from July until July 10 until July 26. So you can see the red color is the forecast, the blue color is the actual. Of course, you can never be 100% accurate. No, it's impossible for 100%. But we are trying to put it at least 80 to 90% accurate. So you can see most of the time, the prediction follow the pattern only on certain days. That's why we need to continue learning. But having this is very good because why? When every day in the morning we feed our production volume for plan for that day, and the solar irradiance are based on our actual site data into the machine, the software, it can predict 30 minutes in advance. So before TMB, the maximum demand hit that one, it predicts, so it can inform the battery management system when to discharge, when not to discharge. So this will improve the accuracy of the discharging and save the energy for the second peak and third peak. Because after you shave one peak, the second highest become the peak. So you have to save enough energy. So we are doing this based on the input of daily volume, production volume, daily solar irradiance, historical production plant load, and load profile into the AI and machine learning algorithm. So they can provide us 30-minute forecast. Of course, this thing is more complicated. I'm not a data scientist. This is what our partner, we have data scientists that work with the University of Monash. They actually help us to improvise our software that integrate. Yeah. If you really want to know more, this is how in detail it is. This is our solar system. This is the battery. This is the inverter, the hybrid inverter that from DC to AC coupling. This is the smart inverter, the solar, and then this is the TMB grid. So this is our factory load. So the formula is the load equals to your grid energy plus your solar plus your battery. However, we add in this thing. This is the AI software we manage. It's running on a Linux OS, more stable. So it actually have two chip, two we call it PLC. So we have this real-time control where we give them the digital input I mentioned, the production volume, the solar irradiance for our solar system, and also it can directly control the inverter and the BESS. And they have a control algorithm written inside the coding with a rule-based control. So the software that we use to write is Python and Node and MySQL. Then TensorFlow and Keras is the AI software that we use to teach them on machine learning. So there is also another PLC with a digital processor that can done forecasting and the day ahead schedule. So all these we have linked to a database, because big data you need to store in database, all the historical load, solar profile and battery. So this is some high level, this is a high level explanation of the software integrated with the hardware battery. Yeah. I will not bore everyone. I think the time is up. We have only 5 minutes more for Q&A. So thank you very much, ladies and gentlemen. Thank you. No more, you can ask.
Hello. I have 3 questions, but I think they're interrelated. Maybe you can take them together. I'll let you know what it is first. Okay. Thank you for this. It was very informative and knowledgeable. In terms of the board level and sustainability efforts of Proton, has the board come up with a sustainability committee which then overlooks whether businesses and everything that you've talked about are implemented? The board sustainability committee that works with the senior management. So that's the first question. Just trying to understand top down how it works in Proton. Second one, sustainability at supplier level. You talked about all this, but what other efforts, like you said, you have a lot of vendors. What other efforts is Proton taking to ensure that its vendors are actually sustainable and practicing sustainability? And the third question is about electric cars. What is Proton's plan in terms of the amount of production of electric cars? Because that's one way we can reduce carbon. But if that happens in relation to the existing amount of cars at the moment, what Are there any plans about recycling the cars that are going out of the system where the EVs are coming in? You see what I mean? What happens to all the existing cars? Yeah, thank you.
Thank you very much for the three wonderful questions. So for the first one, in terms of from our board, the directors, they actually have a steering committee to look after energy sustainability. So we actually form a team because as I mentioned, I started this energy saving in 2013. So that time only me and one staff, one engineer. So we actually doing that energy conservation part-time because we have our own full-time job. So we help the plant people, maintenance people, we went for courses, training. But in 2019, we actually formed a Sustainability Utility Management, SUM group. So I grouped together about 8 engineers, electrical engineers from the various plants in Tanjung Malim, Shah Alam, and our Glenmary, this casting plant, and our HQ, so that we are now having a full-time group of people that actually takes on the sustainability side, the energy efficiency, and also renewable energy. We look for, every year, our KPI is to save how much CO2, and how much, reduce how much electricity costs. End of the day, it also help our bottom line. So we have that unit running, and that unit is actually reporting to me, and I report to the board also. So we have these internal things that we are doing. Of course, we don't publicize, apart from this training, we don't publicize out yet. We are actually reducing carbon footprint over the years. But mainly, last time was cost-driven. Nowadays, it's going towards ESG, like we mentioned. So we need to prepare. And our parent company, DRB HiCom, they actually publish sustainability report every year, SR report, since 2017. So you can look at it. Inside there, every year is a public domain. The SR report, there are the energy green initiative from Proton being published inside there. So you can look at it. So on that, we are doing it. Of course, we have not published yet our this so-called carbon pledge, net zero carbon. I think not many companies can do that in Malaysia because it's not so easy to do net zero carbon. The reason why, because we are producing a lot of petrol car. So the carbon emission in the automotive ecosystem, more than 70% actually come from the usage of the car. Because after the customer buy the car, they use pump petrol every day. So they are actually emitting carbon emission every day. So that amount is very huge, compared to whatever carbon emission we release during our production and end of life recycle of car. That portion is the biggest one. So how we are addressing it, come to the second question, EV. Yes, we are actually putting up EV. Sorry, this is the third question. So this is our EMA 7 that we actually will launch by end of the year. And next year we'll launch another model also. So Proton is also spearheading the local national car into the EV industry. So we are trying to provide affordable, reliable, and long-range EV for the people. Most important is affordable. I think EV is nothing new. In Malaysia, there's so many EV. I think even 10 years ago, they will say EV, but majority of the EV are selling higher. It's about more than 100,000 ringgit, some even 200,000 ringgit. So if your EV is so expensive, majority of us are working level, we can't afford to buy. So it defeats the purpose of transition from petrol-based car to EV, from ICE engine to EV. So the key thing is for national car like us and Perodua, we are tasked by MITI to spearhead the EV transition by having affordable EV. So this is the task that we are doing. The second question. Okay. Okay, for example, so we have a frequent engagement. Like last month, I did a sharing on solar PV with our 300 vendors, because every month we have a vendor briefing. So during the vendor briefing time, I will share the experience and the case study of what we did in Proton. So their plant also have similar system like compressed air, fans, or this, so they can learn from it and practice it. Of course, ultimately, the best is we employ the green procurement element into our purchasing. So if in future, if we do a green procurement policy, meaning any company that want to, supplier that want to do business with Proton, you have to demonstrate your sustainability roadmap, your plan, what you do, what are the initiatives. That will be the ultimate. But at the moment, we are doing the motivation, the coaching way, not the forcing way. Yeah, we hope that it will help them to reduce their electricity costs. So we do a lot of engagement session with them. I even send our team into our supplier plant to help them do energy audit. We went for walkthrough audit. We even loaned them equipment to do detailed energy audit. So we identified where they have this low-hanging fruit, the energy conservation and then the EE. So we encourage them to do that as well. Okay? Thank you.